Well, we got through another exam, so that's good. We're on our way to completing the course. This will be our second to last chapter, chapter 12. We'll spend actually 3 class periods. April 30th is our due date. Guys, remember them concept clips. Don't forget those. Those are due tonight. So May 2nd then is our next scheduled exam date. The last chapter, which is 15, we're only going to spend 2 class periods on. So we will be for sure done about a week before the end of the semester. So that should be good news for everyone. So that's kind of the layout, what we have going forward. Chapter 12 then is about capital investments. And this begins on page 645 of our book. And they talk about Hard Rock Cafe in the example, or the company profile for this chapter, and how they use some of these techniques to evaluate whether they will open a new cafe. So this is the capital investment on new restaurants that they are thinking of going into. And I did find a related article regarding McDonald's. So I do have that in my notes for today. They serve every day 70 million people. That's a lot of food. And with more than 75 burgers sold every second. So I just thought that was kind of interesting. But the real reason I wanted to show this is that McDonald's doesn't make their money on the food. They make their money on the real estate. So it talks about only 5% of them are owned by a person. The rest of the land that they're sitting on are franchised. And they rent out those facilities. There's a fee plus a monthly service fee of 4%. And that's what they make their money on. So take a look at these notes, and it talks about they're not in the business of selling 15-cent hamburgers. That must be what they make per hamburger. They're in the real estate business. So that's how they get their huge volume of money. So that too is what we're looking at. We're looking at this capital investment of many companies, not just McDonald's in this case, but every day companies are looking at their decisions for future progress, new investments in capital. So we're talking about, again, assets, and we're talking about operating assets, because that's how companies make their money. So we're talking buildings, equipment, and another thing that is mentioned in this chapter, something called working capital. All part of this investment process that we are trying to decide whether we should do it or not do it. Because of the dollar volumes associated with this, we're looking at the long-term assets section. So our goal now is to decide which project we need to do or should we do, right? The book, definition-wise again, please know the difference between independent projects and or mutually exclusive projects. This is on page 646 of our book. Independent means if I accept one project, it has no effect on another one. They're each on their own merits. Mutually exclusive, and this is where small companies are. We'd like to do more, but we can't, right? We don't have the cash flow. So if I take one project, if I accept one project, I'm going to have to possibly reject the others. So we'll look at that. We'll use some measurement techniques to decide which one of the group do we take. So that's what mutually exclusive means. I have to reject others to accept the one. So this again would be those multiple choice type questions. Just know the definition for the exam. So the chapter then goes into how do we make a good decision regarding our capital investment. So we got to recover our initial investment, and we also need to make a profit on that investment. And that's what is called the return on the original investment. So recover the outlay plus make a profit on that investment. And that's the goal with every one. So how do we make that decision? Well, we need to know a couple things. Estimate the quantity and timing of cash flow. With risk, there's always uncertainty, right? In any decision we make. There's uncertainty with the environment, there's uncertainty with taxes, there's uncertainty with how much we're going to sell. Lots of uncertainty when we're looking at these big capital projects. And then finally, what's the return in profits that we are looking for? So every one of these problems that we're going to do today will give us a certain return that the company is looking for on making their profit for that particular capital investment. On page 647 then of our book, again some more definitions. Some of the models, some of the techniques we're going to use to pick a project, there are non-discounting. So non-discounting means we ignore the time value of money, as opposed to discounting, which does consider it. Now, does anybody know from economics, who's had economics? We've all had it, right?
I'm in it.
Ooh, good, Carla's in it right now.
Me too.
Are you?
Yep.
Have you talked about the time value of money?
Time value of money?
Yeah, does that ring a bell? No? Okay. Time value of money. $1 today is worth more than $1 tomorrow. $1 today, and this is actually on the test. Time value of money. What's the definition? $1 today is worth more than $1 tomorrow. So wouldn't you like to have $1 in your pocket right now versus a promise to have $1 1 year from now, right? I don't want to wait a year for that $1. So what causes this to happen, or what the discounting model will do, is value that $1 a year or two down the road less in today's dollars. So what they're trying to accomplish here is we have something called inflation, right? Inflation eats away at the value of $1. So that's one problem that's in the future. We also have uncertainty, right? Am I really going to get that $1 in the future? Maybe, maybe not. Or maybe not as much as I thought. So it takes that into play as well. So I'd like to, if everybody has their book, if you could go to page 670. 670. It's the present value tables. You will be using these throughout Chapter 12 to do a discounting problem. If you go across the top row where it says 1%, 2%, 3%, 4, and you go down the column 1, 2, 3, 4, 5, 6, 7 years, you notice my dollar is worth in year 1, column 1, 99 cents. If I go way over to the 10%, after 1 year, my dollar is only worth 90 cents. So that's basically what discounting means. I'm trying to, page 670, Allison. You got her? Chris, you cool? It's on page 670. So a dollar is worth 99 cents in year 1. I'm just using 1% column. If I go to the 10% column, it's only worth 91 cents or 90 cents. So that's what it's trying to predict, right? That's what it's trying to value my dollar in the future. So please know that definition. So our discussion then on these discounting, non-discounting, we're going to start with the non-discounting models. And it's a great tool. Even I use this tool. One of them is called payback period. This is a non-discounting method. And the other one we're going to talk about shortly after the payback is the accounting rate of return. But the payback is one that I use quite often for non-accountants. My boss was a non-accountant. He was a history major. He certainly was not willing to learn discounting models. So payback was the one that we constantly used. In a lot of the equipment we bought, we looked for a 3-year payback. That was his time frame as to what or how long will we have in the future until our investment is paid back. That's what the payback means. How long in the future or how many years does it take before my investment is paid back? So we're going to look at some of that analysis. It shows some things. It can assess risk, and again, risk can be financial as well as obsolescence. Remember, when we buy equipment, there are always newer equipment models coming in the future. Is the investment going to be obsolete after so many years? So we got to be careful about that as well. And then obviously, if I'm investing in something, right, it will affect something else, right? If I'm taking away, or if I'm going to invest in this new equipment, I maybe not be able to give out bonuses or raises. So it's again a catch-22. So how do we compute payback? This discussion begins on page 648. It's a really simple formula. Payback is a period. So the number we're going to generate is in years. And it's really simple. We have the investment dollars on top. And if the cash flow is expected to be even, so much per year, we can divide it by that annual cash flow. Now, there are occasions when the cash flow is not equal. So hence we have another computation for the payback. And example 1 does a nice job of that. So example 1 shows this unequal payback. So let's take a look at it. here are the different, here's the investment, so I'm spending 100,000, and my cash flows are first even in letter A, in B, they are not. Not even in letter B. So this is on page 648 yet. Here's my table. Here's my answer, basically. If the investments are 50,000 even every year, our payback is 2 years. That's letter A's answer. In B, we have to do a table. So this is somewhat helpful when we do our problems. And I like how the table is set up. So in year 1, I have this 100,000. I recover 30,000. So that gives us 1 year has passed. So I subtract then my initial investment 100 minus the 30 gives me the 70 that's left. After year 2, I recover another 40, gives me a whole year, because I still have what? I have $30,000 left. And then at that point, in year 3, at some point, I recover the full 50 or 100,000. So this is where students struggle a little bit. So remember, I had 30 to go. I generated 50 of cash flow coming in, so 30,000 left on my investment. 50,000 is available in year 3. That's 0.6. So basically a little over half that third year is when I finally recover my initial 100,000. So my answer is 2.6. My payback is 2.6 years. On your exam for chapter 12, this is probably one of your easier computations. So with easier ones, you want to make sure you get these right. Any questions on how I got the 0.6 or why we did it that way? Everybody at home okay with that? Okay, good.
Wait, why is it 1 for the other years? What did you divide it? Like if you divided 30 by 50 for that third year, why didn't you divide 7 by, like why is it 1? And the time needed?
Up here, Olivia?
No, like the time needed where the 0.6 is. For the first 2 years,
Oh,
why
here.
are those ones above it?
Because
Why divide it?
I'm using the whole 30,000, right, to offset my 100. And I'm using the whole 40 to offset what's left.
Okay.
But once I hit this third year, I have more coming in than what I need to recover. That's when we start using the division.
Okay.
So think of it at 0.6 years, or at July, let's say, or June, whatever it is. I'll recover 30,000 and I'll be done.
Okay.
So full year, partial year to recover it fully.
Thanks, I got it.
I got it now? Okay. Everybody at home okay? Brianna, okay, Miley's okay, and Eric's okay. Okay, good. Let's try a problem in actual life, real life, I guess. Let's try problem 31, or exercise 31 on page 682. Grab out your calculator, please. Let's get that calculator warmed up. We have 2 different companies here, A and B. And then on the next page, we have two more analysis. So first question is, what is the payback period for Colby? For question 1, question 2, same thing for Kyle. And then we can do some algebra to answer questions 3 and 4. So let's look at Colby first. With payback, we have to make a decision. Is the cash flow even, or is the cash flow not even? So the Colby question on page 682, is that an even cash flow or an uneven cash flow? Even. That one's an even. Very good, Sandy. So here, this is an even cash flow. We can make it very easy. My investment's on top. My annual cash flow's on the bottom then. So we invested $400,000. And what was my cash flow per year? 120, right? Brianna, how much is that? $3.33. Awesome. Thank you. Now in the book they don't tell you how many decimal places to carry. Brianna chose 2 places. In a lot of cases it's 1.
Yeah.
It's usually 1. So if I were to, if the C now is looking for 1 decimal place, what would the answer be? 3.3, right? Very good. So just be aware of that when you're answering the CNAW questions. Watch for the decimal location. Let's do Kyle Sorensen. Again, when we're doing payback, is this even or uneven? Yeah, uneven. Yep, none. So now we got to use the example like we saw on exercise or example 1. We're going to have our investment. Maybe I'll just put this. I'll put year first. 1, 2, 3, 4. We'll have our investment. Allison, what was my investment for this company?
$1,400,000.
Okay, so a large capital investment, right? And then we're going to have the cash flows starting with, I believe, $350 in year 1. So cash flow that we expect to receive each year, $350, correct? So the time frame that has elapsed then is 1 year. So I'm not going to recover in 1 year that investment, so I'm going to use 1 year of my payback. In what do I have left then? Is I simply subtract
$1,050,000.
I pushed the wrong button. Sorry, guys. Allison's right, $1,050,000. And Carla, what's my next cash flow?
The $490,000.
490?
Yeah.
So again, I don't have enough, right? Don't have enough cash flow, so I'm going to burn up another year of payback. Eric, What is my year 3 number then, my starting year 3 number? I'm going to take the 1,050,000 minus the 490. What's left? $560. Awesome. Thank you. Chris, what did I have in year 3 to recover? Year 1?
700,000.
700, okay. More than enough to cover the 560, right? So here's where we do our division. I'm going to drop the zeros. 560 over 700, and that should give me how much? 0.8, right? So 0.8 years, I'll fully recover. My payback is 2.8 years. So if I were doing a test, which one do you think you'll see on the test? The even cash flow? The non-even is what you'll see on the test. So be ready for it. Or I might do both. Just be aware of that. Okay? Everybody comfortable with the format, how we figured it out? Okay, good job, guys. So questions 3 and 4 are just playing off the algebra function of that last formula. In first one, Carson, the payback is 4 years. We are looking for the investment. That's our X. So we're going to use algebra here. And our cash flow is 960. So this is an even cash flow. So how do I solve for X?
Divide both, or multiply both by 960.
Yeah, we got to get X by itself, right? So if I multiply this side of the equation by 960, which is 1, and this side of the equation by 960, I've done the same thing. What do I have left? I have X here, and what do I have here? I have a big number, 3 million something.
840. I don't even know how to pronounce the number.
3 million.
800,040? 840.
840,000.
Yes.
There you go. Okay.
I'm slightly confused how you got that on the calculator.
The 3,000,008.
Oh, times.
Yes.
For some reason my brain was thinking
Oh.
divide.
I times 960 by both sides of the equation to get X by itself. Yep. And then the final one, Ruth's invested 1.3 million in a project that pays him an even amount for 5 years. The payback period is 2.5. So changing gears here a little bit. Payback was how many years? 5? Or 2.5?
2.5.
2.5 is equal to the
Invested is 1,300,000.
and we don't know what the annual cash flow is, right? So that's X. So how do I get X by itself? hard to explain, isn't it? Can I multiply both sides by x? Right? So if I multiply this side by x and this side by x, I have 2.5x equals 1.3 million. Now it's a little easier to solve. Right now, what do I do?
Then you divide the 1.3 by the 2.5?
Yes, very good, Carla. So I've divided this side of the equation by 2.5, this side of the equation by 2.5, and x is left by itself. Gives me what?
520,000.
520. Annual cash flow. Perfect. Super. Well, that's the payback. Pretty straightforward. You'll get practice with your exercises and problems in C now too. So I'm sure you'll do well on this. So one way we can use payback is to give us a rough measurement of risk. And what they're saying, the longer the payback, the more riskier it is. And that's basically true with anything. If it takes me longer to recover my money on my investment, the future is so unknown, and to bring it out further in so many years, it's even more riskier. So if I were looking at these two projects, we have a payback of 3.3 years. And if they were mutually exclusive, and we have another one with 2.8 years, which one would be less risky? The 2.8 would be less risky. The 3.3 would be more, because it's longer in duration. Am I really going to get 120,000 for the next 4 years? Maybe, maybe not. So that's the risk factor. And we certainly can use payback to assess that risk. So that's what it's talking about here on page 649. It's a rough measurement for risk analysis. And everything that we do here today in chapter 12, not only computing the amounts, but it's a measurement of risk. Trying to determine how much risk we're taking on. All right. So it talks about that and liquidity and so forth here. Next, on page 649 and 650, even though payback is easy, right, there are some problems with payback. One of the big problems, it doesn't look at the dollars generated beyond the payback. So once we have our payback number, it ignores that other cash flow. Secondly, it ignores the time value of money. Remember, that dollar a year or 2 or 3 years down the road is worth less than a dollar today. So those are two big problems with the payback method. But again, if you're talking to non-accountants, it's a good number to use. Okay, so our next non-discounting model is called the accounting rate of return. This is on page 650. It measures the return on a project's in terms of income over its basic investment, right? A rate of return, and we've done ROI already. Return on investment, we had income over the investment. That's all it is. It's how much profit are we getting on that investment. Accounting rate of return is the same thing. It's the net income over investment. There really isn't much difference. So problem 2 gives us this model. Here it is in its formula. It's a percent, just like return on investment is a percent. And then they use, as an example, too, it shows on page 651, cash flows. Now, cash flows does not mean income. Cash is actual dollars, right? So we have to convert these cash flows to convert cash flows to net income. Cash flows to net income. So here we have an investment that we're expecting this equipment to last 5 years. It has no salvage value. What is salvage value, guys?
Once it's done, there's nothing we can like do to trade it in or anything.
Well, yeah, if the salvage value is 0, there would be no value. You would just basically scrap it, right? But on a lot of equipment, we can sell it after it's 5 years. We can sell it for something, 10,000, 20,000, whatever the case, right? That's salvage value. What kind of value do I have at the end of the term? And we use salvage value for what depreciation method? Straight line. Straight line method uses salvage value in its computation. So the problem takes these cash flows and converts it to net income. So if you look on page 651, oh my gosh, here are the steps, guys. Now we're not going to do all this work. There's a much easier way to do this. But your first step is to do what? Compute the depreciation expense. Straight line method. We take the cost of the investment to 100,000. What's the 0 here? Yep, Olivia? Yeah, that's the salvage, if there is any. And some of your problems will have salvage value, some will not. So this one does not, so that's why it's 0. And then divide by 5, which is the years or life of the asset. That depreciation amount is 20,000. Next, we take the cash flow, which is dollars, right? We subtract the depreciation expense of 20, gives us what? Our profit or net income. So each year we do that, and then we average those. We add them up. That totals up to 180,000. We divide by 5. Our average net income is 36,000. And that's what we divide by the 100,000 investment. Gives us our 36% accounting rate of return. I know they have 0.36 here, but normally it is a percentage. It's a percentage number. So in other words, if I invest 180,000, I'll recover my investment, right, after 5 years, plus I'll make 36%. Not bad. Should we do it easier? Let's do an easier way to do this. Let's try it. So here we go. Let's try problem 32. Page 683. I'm going to move this down because I think I'm going to run out of room otherwise. What's my investment at, what's Cabri looking? How big is their investment? Yeah. So step one, remember we have to compute our depreciation expense. Carla, what was it again?
3,600,000.
Was there any salvage value?
No.
And how many years?
5.
Miley, are you still here? How much depreciation, Miley, do I have then? I think she gets her kids pretty close to this time. 3.6 divided by 5 years. Maybe she stepped away. Brianna, do you have a number? $720. That look good, guys? Thank you, Brianna. So that's $720 per year. So this is where I'm going to be different than the book example. So what I do instead, since it's the same amount every year, I'm not going to do year 1, 2, 3, 4, 5. The average cash flow is the sales minus the expenses, which in this case is 6 million minus 4.8 million. Gives me 1.2 million. The author sometimes calls this 1.2 million net cash flow. What does the word net mean? We're usually subtracting something to get a smaller number, right? We're netting the two numbers together. So that's what we're doing here. We've taken our sales, which is a plus cash, right? We subtract the expenses, which is a minus cash, and we get our net cash flow of 1.2 million. So look for that word net cash flow in your examples and problems. We've got to convert this cash to profit. The way we do that is we subtract out the $720,000 of depreciation. And we should get 480. And that's per year. Because look at the cash flows in year 2, 3, 4, 5. They're all the same numbers, right? So it'd be silly for us to take 480 plus 480 plus 480 and divide by 5. I already have it. It's the average is 480. So I can simply then divide by the investment, 3,600,000, because this truly is, this 480 is the average income. And that's what we're looking for. That average income of 480 divided by 3.6 million, which was our investment, gives us an accounting rate of return of how much?
So it's like 13%.
Thir-
You rounded to 2 decimals, right? Or
What's the decimal first, Carla?
it's 0.13333.
Like that?
Yeah.
Which translates to 13.3%. Correct. Just move it over 2 decimal places to get your percent number. And I don't think, Carla, did it say anything about how many decimal places?
No.
On your See Now assignments, it will tell you 1 place, 2 places as a percent. Yep. Okay. So how did this flow? Okay for everyone? Okay. Let's do project A and B. Let's do project A before break here. Emily is considering investing in 2 projects, A and B. Both projects will require 75. So they're looking at a mutually exclusive example here. They can only do A or B. They can't do both. So let's do the accounting rate of return. There is no salvage value. So step 1, depreciation. We're going to take our 75,000. I'm going to minus 0, divide it by 5 years. It is 5 years, right? Yep. And that gives us how much? 15,000, right? Yeah. That's my depreciation expense, 15.
100. Was it 750 or 70?
I thought it was 75 only,
Oh, it is.
Sandy.
Okay. I put an extra 0.
Okay, let's compute our average income then. That's step 2. So here's what I'd like you to do for accounting rate of return. Let's simply add up the cash flows. 22.5, 30, 45, 75, 75. So 22.5 plus 30 plus 45 plus 75 plus 75. We're going to add them all up, and we've got 5 years here, right? That looks like a 6. Gives me how much?
$247,500. Oh, sorry, that was 10. I didn't divide it.
Oh, give me that number, Allison. 247 what?
247,500.
And that number is divided by 5, and we get how much?
49,500.
Okay. But remember, that's just average cash flow, right? So now I'm going to take that 49,000. I'm going to do step 3 here. I'm going to take the 49,500, subtract off the 15,000 of depreciation expense. Oops. And what is that difference?
34,500.
And that's my profit, or net income, right? And that's what I'm shooting for. And that's when I divide my investment of 75,000, gives me an accounting rate of return of how much?
0.46 or 46%.
There we go. Awesome. Really good return, right? Really good return.
That's just for project A.
That's just for project A. Correct. Now, we don't have to do much more for project B. We have the same depreciation value, 15. So for project B, we can already start at step 2. Let's take our average cash flow numbers. Sales minus expenses is our net cash flow, 22.5 plus 30 plus 45 plus 22.5 plus 22.5. We add them all up, divide by 5, and what do we get for our average?
And adding them all up is 142,500.
Brianna, 28.5? Does that look good, guys? Thank you. 28.5 is our average cash flow. I have to subtract my 15,000 of depreciation. Gives me a whopping 13,500. I divide by 75. The net investment amount is 75, and my accounting rate of return, Eric or Brianna, 18%. Eric, you got her? I'm assuming by no answer means yes. Okay, let's do her, 18%. So which project is better? Project A, right? This is the best project of the two because it has a higher accounting rate of return. Now, can I have you turn before you take break here? Can I have you go to page 680 of your book? Problem 22. It's an accounting rate of return problem. The word I want you to find is you see that word? Net income stream is? There's a difference between net income stream and cash flow stream. If it says net income stream, it already has the depreciation subtracted. So don't go to this problem and think you have to subtract the depreciation again, right? If it says cash flow stream there is no depreciation removed. There is no depreciation in that number. Depreciation is what? A non-cash expense, right? So obviously depreciation would not be in a cash flow stream because it's a non-cash expense. Whereas if it says net income stream, then it does have the depreciation taken out. So on problem 22, remember how we did the steps here? We added up in step 2 the cash flows, right? Got an average, and then we subtracted out the depreciation.
You just don't have to subtract, you just take that number divided by.
Yes, very good. Yes, for problem 22, the depreciation is already removed. Just add them up and divide by,
7, or the 9 million.
no, divide by the 7 to get the average per year, and then divide by the 9. That's your accounting rate of return. So very tricky. So just a different word going from cash flow to net income changes the problem and how you find it. So that's what I kind of want you to watch for. Otherwise you'll get a negative accounting rate of return if you do it and subtract the depreciation out again. Okay, let's take our first break, guys. We'll stop here and we'll pick up on our discounting. All right, to wrap up the accounting rate of return then, we have some limitations. With all of our techniques or model tools that we're using today, there are limitations to all of them. And the accounting rate of return is no different. It's non-discounting, so again, the biggest problem with the accounting rate of return is it ignores the time value of money. In addition to that limitation, I like this. We're dependent upon net income. And net income is a measurement that can be manipulated, right? So here again is my example. If somebody asks me what was the net income for the month, and I can say, well, what number do you want? And we do, as accountants, have some flexibility in how we report our expenses and income. We have to follow GAAP rules. I'm not saying you don't follow those rules, but certainly we have some leeway, right? And that's what they're talking about here. And also, we have a concern with managers' performance, right? They get paid on their net income, they get paid on their return on assets. They will always pick the project with the highest net income. However, that's a short-term look. Remember, cash flows might be longer than a couple years. It might be 10 years out, 20 years out. So that's another problem with the accounting rate of return, is that short-term focus. So just be aware that's for those multiple choice type questions. What are the limitations of the accounting rate of return? Now, what we go to next are our discounting models, which begin on page 652. These are the predominant models used in a lot of analysis for our capital investments. They do include the time value of money, and we are going to use discounting models, one of them called net present value, NPV, and the other one we're going to use on our discounting model is IRR, internal rate of return. These are both discounting models. Net present value, internal rate of return. And what net present value means, again, it has the word net in it. I'm netting two numbers together. I'm comparing my investment dollars. So this is usually a negative. I'm spending my investment and I'm comparing it to my cash flow dollars. And hopefully my cash flow from that investment is going to be bigger than my investment, right? So I'm looking for a positive number here when we're deciding whether to do a project or initiate a capital investment. Here's the formula. You can do this in Excel, guys, right here. Isn't that wonderful? But that's the actual net present value computation. But we won't do that. I just wanted to show it just for fun. I like showing that. Basically, what is it? It's the summation of the cash flows over 1 plus the interest rate at t to the time power, and then you subtract 1. Cool. All right. That's not on the test, by the way. Net present value, what is it? Profitability of the investment. We're looking for a positive net present value, right? That will show that it's going to increase the firm's wealth. To do a net present value, we have to find out what the company's desired rate of return is. Remember from chapter, where did we come from? Chapter 8. Is that where we came from? What did we just test on?
Oh, chapter 11?
Oh, chapter 11. Yeah, thank you, Carla. Chapter 11, we talked about return on investment. Well, this is kind of the same thing. What is the desired return that the company wants? And we also mentioned last chapter, it's also known as the discount rate, the hurdle rate, the cost of capital. All similar terms for this company desired rate of return. So know all those differences. This is on the bottom of page 652 and the top of page 653. On page 653 then, we'll talk about that shortly. If the net present value is greater than 0, it's acceptable. The project is acceptable. And what does this positive net present value tell us? That we've recovered, 1, the investment. We've also made the desired profit, and we have an excess. So it's done better than what the company desires. We've actually made a better return than the company rate of return. It has all that in one number. It tells us all of that, if it's positive. If it's negative, then we didn't either recover our investment or we didn't recover the company's profit that they want on that investment. So lots of information from one number is given to us. So please know this for the exam. What does a positive net present value give us? It gives us that it's recovered the investment, it's given us the required rate of return plus an excess of that return. If it's 0, we could do either way. If it's less than 0, we don't do the investment. Exercise 3 is the example. So let's take a look at this. It's always good to look at this and how they set it up. Example 3 is on page 653. Lots of things going on here. So rather than read all this, the author does a nice job of taking this problem and putting it in a table. So here's my table. So if you can turn to page 653, I'd like to make some notes on here. I'm sorry that it's a little grainy. I was blowing it up as best I could. So if you notice here, I have my investment, $320,000 in some type of equipment. Then they also spent $40,000 additional dollars in year 0. Here's the present. This is what I'm doing right today. I'm spending that money. Working capital is, I'm going to need supplies to run this machine, some inventory to run this machine, some maybe cash. I'm going to have some sales, which I'm going to have to, basically put on credit, so I don't have that cash either, right? So all those things I'm buying to make that machine workable is called working capital. So I'm spending that amount of money. So my total investment in year 0 is $360,000. So when you get to these problems, guys, when you get to these problems, it'll be in a word problem, right? You've got to convert that into a table like this. It makes it much, much easier to solve. So, this is a 5-year project. We're expecting this to last 5 years. In years 1 through 4, the net cash flow is $120,000. So, we're switching gears now. We're going from accounting profit to what? Cash flow. The net present value has to be cash flow dollars. There's no depreciation here. So, if I ask you for a net present value, guess what I'm going to also give you? The depreciation expense was $50,000 per year. What do you do with that number? I do nothing with that number. Did everybody hear what I just said? Should I repeat it? If I'm looking for a net present value, and I give you depreciation was $50,000 per year, I don't do anything with that number on a net present value computation. That's what I need you to know. Why would I throw that depreciation number in there?
See if you're paying attention.
Yes, to see if you're going to use it. When do I use it? Which computation will I use the 50? On the accounting rate of return. So be careful, be careful, be careful. All right? Now, so for 4 years I get 120. In the 5th year, oh my gosh, look what's happening. I still make the revenue and expense number of a net of 120, but look it. I'm going to sell it for 40, and I'm going to sell the working capital, the supplies and everything, the inventory, for another 40. So these are 2 positive numbers in year 5. So in year 5, I get $200,000. Then we got to discount these all forward to present dollars. Oh my gosh, look at this. Here we go. Can I have you turn again to page I'm looking for the tables. 670. It's called discount factors. Page 670. You should see these numbers. Look in column, the 12% column. The company's desired rate of return is 12%. That's what they're expecting on this investment. So if you go down the 12% column, after year one, my dollar is worth 89 cents. After year two, my dollar is worth 79 cents. This is on page 670. After year three, my dollar is worth 71 cents. So that's where these numbers are coming from. So I'm converting these future dollars, right? 1 year, 2 years, 3, 4, 5 years down the road to today's dollars. What is this worth to me today? Well, 120,000 at 89 cents, that 120 in today's dollars is worth 107. My next 120, 2 years from now, is only worth 79 cents in today's dollars. My 120 is 95,000. So I'm comparing my negative investment to my positive flows, and I get a net present value of 117,969. So should we do the project? Yep. We should. It's a positive number. Now, we can do it a simpler way. Go to the next table. And page 671. %, column, row 4. Do you see the 3.03735? Right? So for 4 years straight, 1 through 4, I get in 120. It's an even cash flow. If it's an even cash flow for a certain period of years, I can use the other table. What's that table called? It's called an annuity. You ever hear that term in insurance? It's an annuity. I'll get so much per year for the rest of my life. That's an annuity. Versus a lump sum today, one number. And the 5th year is a different number, right? Mm-hmm. So I can't use the annuity for 5 years. I got to go back to the page 670 because it only happens once. It's a 1-year deal, right? I got to go back to the other table to discount it back 5 years now to present dollars. Do I get the same answer? Yep, I get the same answer, just using the annuity table instead of the present value. You have to understand these two tables and the difference. Also recommended as a ruler, because it's so easy to grab the wrong row, the wrong column, and you start discounting, and oh, you don't have the right answer. And then you get mad at C now. Is it a rounding error? And sometimes it's not. It's because you've taken the wrong row. It's very easy to make a mistake. Are you itching to use your calculator? Let's try it. I wish I could make this bigger, guys, but I can't. So, guys at home, I mentioned it to here already. We're going to use the second row. second function, CF, NPV, IRR. That's all we're going to need in chapter 12 here to do that second row on your calculator. Does that make sense? Do you have your calculators out? Yeah. All right, thanks, guys. Who else is with us? Oh, just Brianna and Eric, you're the only ones left. All right, let's look at our problem. We want to use these same numbers as our problem in the book. 360,000. Let's put it in our calculator. Go to the CF button, click on CF. It should say cash flow in year 0. So type in 360,000 negative. Hit the negative symbol because we spent the money, right? And the enter button is right above the CF. Click on the enter button, right above the CF. It should say the word enter.
Mm-hmm.
Does it say that?
Yeah.
Okay. All right. Use your down arrow. It's called INS, insert. Down arrow, you should see cash flow in year 1, 01. And I'm going to put 120,000 in. And make sure you hit the enter above the CF to enter that 120 in. Down arrow again. F means year. I don't know why it does. F means years. How many years did we get the 120 in a row? 4. So type in 4 and hit enter. 4 years we got the 120. Press the down arrow again onto the insert. What's the other cash flow that I'm getting? The 200,000. So enter the 200,000. Make sure you hit the enter. Down arrow. How many years did I get the 200? 1. It defaults to 1. So right now, we've told the calculator what our cash flows are. The amount going out and the amount coming in for over the 5 years. Go to the middle button, NPV. Hit the middle button, NPV. What was the interest rate that the company desired? The 12. So type in 12, no decimal, just 12, enter. Brianna, Eric, are we good so far? I think everybody here is following pretty good. Okay. All right. So once I have the 12 in, press the down arrow. It should say NPV on your calculator. Hit CPT. It's the upper left corner next to the enter button. And you should get 117,967.293. Is that pretty close to what we had? Yep. Yep. Okay, that's it. What do you think? I like to use the calculator because I'm not looking up tables. There's too many mistakes on that table thing. But it's a great way to do it both ways, right? You can use the tables, figure it out, try it in your calculator, figure it out. We'll practice more as we do more of these. Go over to the IRR, which is the 4th button over, right here, IRR, and then just hit compute. It says 23.59%. So what this is telling me, we have a positive 117,000, right? That means internally I've made 23, almost 24% on it versus the 12 that the company wants. So it's a very good project for us. We're making 24% on our investment. And that's 12 percentage points above the company's 12% desired. So it's really a good investment. That's what internal rate of return is. obviously we'll practice these as we go through our examples. Let's try one problem before you leave today. The problem is 33. 33, guys. These are even cash flows. They're a little bit nicer, easier to do. We'll do it manually using the tables and then also using our calculator. For problem 33, Campbell is looking at some new equipment, new welding equipment. The cost of the welding equipment is $2.7 million. They assume that this new welding system will generate benefits of $480,000 per year. That's real dollars, that's not accounting. And the desired company rate of return is 12%. So, this is even cash flow. I get the 480 every year, oops, for 10 years. What table do I use to discount that 480?
Is that the
Annuity. Very good. Right? Is that what you're going to say, Carla? Yes. The annuity table on page 671. This is an annuity. If I get the same amount for a number of years, I can use the annuity table. So 480,000. But what's my discount factor? The author calls this the discount factor. What number is it? I'm going to multiply this by the discount factor. Page 671. Look at the 12% column. Go down to year 10, and what do you get?
5.65022.
Yes, that's it, Carla. Does everybody see that number? 5.65022. 12% column, 10 year. Seems like such a big number. Carla, how much do you get then?
If you multiply that by the 480,
Yep.
$2,712,10. Oh wow. It's okay. 2,712,105.
Yep. 712,505.
105.
105.
And then it's 0.6. I don't know if you want to include that or not.
Nah, it's, at this point, that's such a big number. Whether I'm off a buck or two. What did I spend though?
2,700,000.
So my net present value, because this is a negative, right? That's the outflow going out. My inflow is the black number coming in. I'm still at a positive net present value. So should I do the project? Yes.
Very close, but
Yeah, it's very close, which would make me nervous, would it not? Because what if I'm off on this cash flow just a little bit? 470 might even put me in the negative range. So it is positive net present value. We would accept the project. That's what we're trying to get to. Let's try our calculator to see if we get the same answer. So here we are, calculator time. If you click on the CF again, please clear it out. So click on CF, you should have CFO. Hit the clear work on your calculator. Oh, second function, clear work. There you go. Sorry, I forgot the second function. So second function, clear work. You should have zeros before you start this problem. We spent 2.7 million. Negative. Make sure you remember the negative, because that's what we're spending. Enter that number. Is everybody okay? 2.7 million spent. Down arrow. What was our annual cash flow? 480. Enter that. 480,000. How many years though?
10.
So down arrow again. Make that 1 a 10 and enter that. That's our cash flows. Pretty simple. They're annuities. Really quick. So now go to the next button, the net present value. What was the interest rate that the author or the company wanted?
12%.
12. So type in 12 again. Enter that. Down arrow. Are we good? It should say NPV now. Hit compute. The upper left corner. 12,107. So I'm off a couple bucks on my calculator. Now the C now answers will always be the table answers. They will not be your calculator answers. Your calculator is there just for double check it. Correct. Now on the test, I don't care which method you choose. If you use your calculator for the test, I will go through the test, and for those that are marked off because it's $1 different, I will correct that and make it normal. So you can use your tables on the test, or you can use your calculator on the test. Whatever you're more comfortable with. Okay guys, I think I'm going to stop here at this point. I guess a start on looking at our calculator and using our cash flow off our calculators. And Thursday we'll continue this process. Also on Thursday we'll talk about the project, because I got to give you a few more pointers on that project. Otherwise, you might have a lot of questions on it. So just remember that for Thursday coming up. Okay, guys, that's all I have for today. Enjoy the rest of the sunlight that you see out there. I'll see you on Thursday.